This is John Black, Super Chemist. Anyways, I'm just putting a few videos out there about learning because I'm going to start up a second channel about learning. And my idea about having a flash channel, I'm just going to keep the flash on this channel. So I'll have a learning channel about books, and I'll have a, in the lab type of learning. Seeing how if anyone likes these videos, or, if they have any questions, I'll answer any question you got if you're trying to learn chemistry. Doing an easy video. I'm not going to go into too much about it, but it's called nomenclature. Nomenclature. It's basically just how you name stuff. A hydrocarbon. What's a hydrocarbon? A hydrocarbon is anything that has hydrogen and carbon in it, right? If it has anything else in it, it's technically not a pure hydrocarbon. But let's talk about that. Let's say it has one carbon in it. Now, hydrocarbons, you got a carbon. All your carbons are surrounded by hydrogens, unless they're connected to another carbon. Let's say there's one carbon. That means it's methane, okay? That means it's one carbon surrounded by 4 hydrogens. Let's say it's 2 carbons. Now it's ethane. 3 carbons, propane, and so on, okay? Now, when you have a single bond, it's called an alkane. When you have a double bond, it's called an alkene. When you have a triple bond, it's called an alkyne. You can see the ending, A-E-Y. That denotes the difference, okay? Now watch when you name something. Now methane obviously can't have a double bond. It's only got 1 carbon. Ethane can have a double bond. Now what happens if ethane has a double bond? You just change the last part, the A, change it to an E. That's it. That means it's a double bond. What about propane? Now it can have triple bond because it got 3 carbons. So actually ethane can have a triple bond too, now that I think about it. It'd be ethine or acetylene. I don't like acetylene. I hate those old names. I like the new name. I mean the IUPAC name. Anyways, propane, you take the A out and put an E in for a double bond, propene. If it was a triple bond in there, you'd make it propyne. You can see I'm just doing the same thing with each one of these. I only went up to pentane, but you can see pentene, pentyne, butane, butene, butyne, alkane, alkene, alkyne, A-E-I. So if you want to learn chemistry, even the basics, you need to learn. I mean, if you can't learn these couple videos that I put up so far about chemistry that are just about the book stuff, I mean, you'll never learn chemistry then. I mean, you can't. It's not possible. Now, you'll see my prefix here is for each of these. Methyl, meth, ethyl, propyl, prop, butyl, bute. You see what I'm getting at? Now, how do you name an alcohol? First, you see how you name the hydrocarbon. If it has 10 carbons, it's a decane, nonane, octane. And you can relate these words to something. Not these ones up here, maybe, but some of these down here, like hex. Hex is always associated with 6. The devil, I'm going to put a hex on you, 666. A hexagon, hept. Can't think of anything with that one except for a heptagon. But everyone knows an octagon has 8, right? How about a pentagram? That's a 5-pointed star. I relate that to that. If you know other languages, D and N is usually, an O. These are all basically, if you know other languages, you'll realize how they're related. But anyways, to get back to the point, so these are what they are called if it is a pure hydrocarbon, right? Just straight chain hydrocarbon. Well, you might say, well, what does the methyl part, why are you putting a YL on these? That means it's a carbocation. Let's say I had methane, right? Let's say I take off a hydride, one of the hydrogens. I would be left with a methyl group, right? Now, if I replace that hydride with an OH, right? An alcohol. Now I have an alcohol. But that's why some people call this methyl alcohol, because you got a methyl group and you have an alcohol group. Methyl alcohol. Ethyl alcohol. You got an ethyl group and you got an alcohol group. But if you take the alcohol group off, then you just have an ethyl group. And most likely it's a carbocation. It's positive. Um, so that's why when you group stuff up, like this, if you have one carbon and it's attached to something that's, it might be a methyl group. They might call it methyl, because it's not the main part of the skeletal, compound. It's just a little group hanging off of it. You know what I mean? So they might call it ethyl, but the main chain has 10 carbons. This is just a substituent. If it's a substituent, like just a little piece, you could call it ethyl. Ethyl alcohol, propyl alcohol, butyl alcohol, pentyl alcohol. Now, if you have an OH on it, it's an alcohol, right? So what happens if you have one carbon with an OH? It's methanol. See, methanol. Methanol. Just take the E off and put an OL, right? Same with ethyl. What if you have two carbons like ethanol? Call it ethanol. You have 3 carbons with an alcohol. Propanol. Butanol, pentanol, hexanol. You're just taking the E off and putting an OL on. That's it. So, I hope this helps and it's the same with any functional group. If I have a carbonyl group at the end and I have one carbon, then it's an aldehyde. I'd call that methanal. AL, not OL. I'd call this ethanal, propanal. If it had a carboxylate at the end, it was a carboxylic acid, I'd call it methanoic acid, ethanoic acid, propanoic acid, butanoic acid. See how I keep the same beginning? The beginning tells you how many carbons there is. The end tells you what the functional group is. Now the middle part of it tells you whether it's a single, double, or triple bond. Look how I underlined it. You can't see it, but that's where it says AN, because it's an alkane. See, alkane. Each one of these things at the end tells you something. If it's a YL at the end, it means it's an alkyl group, some kind of hydrocarbon, carbocation. If it has a ANE at the end, it means it's an alkane. If it has an OL at the end, it's an alcohol. OIC, carboxylic acid. Now you can't have a double bond with one carbon, but if it had 2 carbons, it'd be alkene. See right here, I got a double bond. There's 2 carbons, 1 carbon, 2 carbons, right? So instead of it being ethane, it's ethene because it's a double bond. Let's do an example. We'll do an example with carbon number 1. What does meth mean? Meth means 1 carbon, right? What does methyl mean? That means, right, 1 carbon means meth. YL means that it's an alkyl group, meaning that they took a hydride off. What's methane? It's meth means 1 carbon and it's surrounded by hydrogens. Methanol, same thing. Meth, 1 carbon. Methane, surrounded by hydrogens, but you can see they took the E off and put an OL on there. So that means that they replaced the hydride with an alcohol. See the picture of it? It's the same. See how these are all so similar? They got 1 carbon, 3 hydrogens, 1 carbon, 4 hydrogens. And they keep having one, you know what I mean? They're just replacing something. Methanal, which is an aldehyde, they're going to take off 2 hydrogens, 1 off the oxygen and 1 off of here, right? Then you got a bond here. That'd be methanal. The Al means aldehyde. If it's in carboxylic acid, then you got methanoic acid. See how that works out? Alright, now we're going to read this molecule right here and we're going to draw it. 2-methyl, 5-amino, 3-ethyl, hexanoic acid. I know if you don't know anything about chemistry, you know what I mean? You're like, oh, that's crazy. I'm not going to know that. But I want you to think about it. One thing you need to know is that all this garbage beforehand, 2-methyl, 5 this, 7 that, whatever, that tells you what's on the molecule. But the main part, or the skeletal part of the molecule, is at the very end of what they're saying. And what they're saying at the end is hexanoic acid. So let's start with that. Hexanoic acid. We know that hex is 6 carbons, right? Hexane, right? Hexane has 6 carbons. Let's draw that first. 1, 2, 3, 4, 5, 6. So I got 6 carbons there. 1, 2, 3, 4, 5, 6. So that's what hexane is, right? And there it is, hexane. But we took the E off at the end and we put an oic acid. So we know it's an acid, okay? You might not know the functional group for an acid, so I'm just going to draw it on there. So now we got a picture of hexanoic acid. If you knew your functional groups, you would just draw it on there. You have to learn your functional groups, but if you did know them, that's how easy it is. Hexane, I draw hexane. They took off the E and made it into an oic acid, so I put a carboxylic acid at the end. Now that we have the main skeletal formula, the main part of it, then we start at the beginning. Now, you always start numbering your carbons wherever your main functional group is. We only have, see, there's our main functional group. So that'd be carbon 1, carbon 2, 3, 4, 5, 6. All right, so now we start at the beginning here. 2-methyl. Remember we said meth is 1 carbon, and if we have, oh, should be a Y in there in between that H and the L. But we said that's a carbocation. That's just a positive part. It's 1 C surrounded by H's. And we don't draw H's, as you can tell, unless it's on a functional group. So why don't we just count over? There's carbon 1, carbon 2. We'll put a methyl group on, 1 carbon. Now we have 5 aminos. So we go 1, 2, 3, 4, 5. And we draw an amino group. You might not know what an amino group was, but if you did, you'd know that's where you draw it at 5. And it says 3-ethyl. So we just count out 3. 1, 2, 3. And we put an ethyl group on there. Ethyl, remember, eth is 2 carbons. Ethane would be, ethyl. We're putting an ethyl group on. 1, 2. And that's basically it. Now, I actually didn't do this right. You're supposed to do it in alphabetical order. I don't know why they do it in alphabetical order. They should do it in numerical order, which I didn't do it that way either. But my point is it's that easy for a big molecule like this to draw it. You know what I mean? If you know your functional groups and you know your meth, eth, prop, but, pent, hex, hept, oct, non, dec, you know what I mean? You know all those prefixes, right? And you also know alkane, alkene, alkyne. And you're just changing just little parts. This is the same word. You're just changing one letter out of each thing. You know what I mean? If you figure out what chemists like to do is they like to take little parts of words and jump them together. You know what I mean? So that it makes some giant word. But all it is basically little words. It's just this is just a sentence. And the sentence says, I have hexanoic acid, and at position 2, or carbon 2, I have a methyl group. At carbon 5, I have an amino group. At carbon 3, I have an ethyl group. That's all that sentence says. That's basically all there is to name and stuff. I mean, I know I'm just giving you a little taste of it. There's a lot more than this. But just to give you the gist. Anyway, I hope this helps some people. Have a great day, and always remember, science is great.